Hi everyone, my name is Leo and my team name is Namco. Today I will introduce the methodology we apply to our AI cross project. Pacman contest capture the flag. In this contest, we need to apply AI techniques to drive our agent not only to eat opponent's food but also protect our own food. In our design, we have developed a defensive agent to protect our own food and an offensive agent to grab foods which belongs to our opponents. For our offensive agent, the first requirement is to eat as much food as it can. We developed the Monte Carlo search tree for it to evaluate the next action it should take. We set up several kinds of features such as remained food, distance to food, remained capsule, and given each feature a corresponding weight. Also, we apply goal recognition for predicting actions of opponents. We assuming opponent's defender will go to defend their food which is closest to us. We keep this assumption until we observe our opponents and re-estimate where the defender may be. By this means, our offensive agent can avoid being observed by opponent's ghost. As Pacman will become invincible after eating the capsule, it should focus on food after eating a capsule. Therefore, the feature number has been reduced in such a situation and only features related to food have been kept. After our Pacman has obtained certain amount of food and being chased by opponent's defender, we need to ensure our Pacman go home safely to score. To ensure that we first eliminate all successors of current game state that leads to dead end using a recursion function. Then we check if remaining successors are danger zone, which means place will be eaten by ghosts immediately or next step. Also, if there are still capsules available and it is closer to our Pacman comparing to Ghost, we will take that capsule to optimize our benefits. For defensive agent, there are two situations it needs to face. Defensive situation, which means opponent's Pacman haven't get capsule or capsule effect is timed out. In this case, our ghost is responsible for defending food in our territory. It used a A-star algorithm to calculate the distance to lost food and achieve heuristic search. Use the Manhattan distance as our heuristic function, applying to a A-star algorithm for predicting the distance from the current position to the goal position. Scare situation, which means opponent's Pacman has eaten capsule and our ghost can be eaten. As our ghost is afraid, let our ghost become responsible to eat food in enemy's territory. It uses the linear combination value of feature and corresponding fixed weight to make decisions. During our development, we have faced several challenges. Due to limitation of computing time, we are not able to generate a Monte Carlo search tree with enough numbers of iteration and simulation that can search the food far away. Other than that, suitable features and weight needs a lot of experiment to decide. When the defensive agent chases the invader one step behind, the problem is the defender cannot catch the invader. If the invader goes back home after eating a lot of food instead of going to a dead end. When our competitor used two offensive agents, only one defensive agent is not enough and it is hard to decide which Pacman we should chase. If we can spend more time on this project, there are several possible improvements we can do. For offensive agent, we can add defensive ability to it. For example, when our defending capsule has been eaten and scare time has been passed, if we have higher score than the other side, we can also use our offensive agent to do the defensive task. Second improvement can be utilized 15 seconds to calculate the dense food area during initialization. Using multiple Monte Carlo tree also can help. We can generate a random forest of Monte Carlo search tree to make a decision through these trees. For defensive agent, apply goal recognition to determine which exit opponent's Pacman will take instead of chasing behind them. Also, we can increase the attack ability when the ghost is scared. Here is an attack demo. Green area shows the simulation of Monte Carlo search tree. As we have observed a ghost, our offensive agent will estimate the best entry point. However, due to the limitation of computing time, simulation area cannot cover many food, which leads to our Pacman may make some bad decisions sometimes. This is a defensive demo which shows our defensive agent will use Manhattan distance to lost food location as heuristic function applied to A-star algorithm. This allows our ghost to chase the Pacman. While opponent's Pacman ate the capsule, our defensive agent will try to eat some food, and when the scare time is going to pass, it will go to defend our food again. This tournament case shows the disadvantage of Monte Carlo tree. As the offensive agent is far from food, MCT seldom has a simulation that obtains food, which leads to our Pacman wasted plenty of time. That's all for our presentation. Thank you so much for listening to us.